A web browser is a code interpreter that takes HTML and script code to present a document to the user in an attractive and useful format, including text, images, and video clips. It allows the user to interact with dynamic elements including search fields, hyperlinks, forms, video and audio controls, and many others. There are many ways for an application to manage this dynamic interaction with users. The one way that is most common in today's web applications is the use of client-side script code, which means the server sends code to the client and it will be executed by the web browser. When the user input is used to determine the script code behavior, and this input is not correctly validated and sanitized in order to prevent it from containing code, rather than information, the injected code will be executed by the browser and you will have a cross-site scripting, XSS, vulnerability. Hello everyone, welcome back again. In this video, we will be going to explore cross-site scripting. Let's take a look at, what is it? XSS is a type of code injection that happens when script code is added to the user's input and processed as code instead of data by the web browser, which then executes it by altering the way the user sees the page and/or its functionality. Let's first explain the scripting part of cross-site scripting. Most major websites today use JavaScript, or sometimes VB Script, to perform calculations, page formatting, cookie management, and other client-side actions. This type of script is run on the browsing user's computer, client-side, within the web browser, not on the web server itself. Let's explain it with a simple example. In this simple example, the web page instructed the web browser via JavaScript to write the text. A script was used to display this text. The resulting page looks like this when the web browser executes this script. The user browsing this website would have no idea that script running locally transformed the web page's content. From the rendered view within the browser, it doesn't appear to be any different from a static HTML page. Only if a user were to look at the HTML source could they see the JavaScript. Scripting support is included in most browsers and is typically enabled by default. Web application developers have become accustomed to using scripts to automate client-side functions. It is important to note that the script being enabled and used is not the cause of the vulnerabilities. It is only when a web application developer makes a mistake that scripting becomes dangerous. Without web application flaws, scripting is safe and is a good tool to enable a rich user experience. Now, let me explain cross-site scripting. Web application flaws that lead to cross-site scripting are generally input validation vulnerabilities. A successful XSS attack involves two steps. First, the attackers send a request to a web application that the web application does not properly sanitize or validate as being properly formatted. Second, the web application returns to the attacker without encoding a web response page that includes the improperly formatted input. Some examples of the characters that are used for XSS include ampersand, left and right angle bracket, double quote, single quote, and forward slash. These characters should be encoded, preferably using hex or escaped when being returned to the browser. The OWASP Cross-Site Scripting Prevention Cheat Sheet is a project that provides guidance on properly protecting against XSS. It can be found on this web page. There are three major categories of cross-site scripting. They are reflected XSS, stored XSS, and DOM-based XSS. Let's first take a look at reflected XSS. Reflected XSS is one of the most widely exploited web application vulnerabilities. To exploit this vulnerability, the application takes one or more parameters as input, which is reflected back to the web page generated by the application. This may not sound harmful at the moment, but this vulnerability can be exploited to do one of the following things or more. It can execute malicious JavaScript code, or execute client-side exploits, or bypass CSRF protections, or temporary defacements and other nuisance. The first instance is of quite a concern, as this allows a hacker to execute client-side JavaScript code of his choice to be rendered and executed by the browser of the victim or the viewer viewing the page. In this case, it gets worse when the session or other essential cookies of the user are available to be stolen through the document.cookie property of JavaScript. Consider the following JavaScript code. This code, if executed on a browser, will transfer all the cookies that fall under the origin of the web page to evil.example.com as soon as it gets loaded. However, there is an exception. Cookies marked with HTTP only will not be transferred, as this acts as a defensive measure to prevent marked cookies from being accessed through document.cookie. Demonstrating reflected XSS vulnerability. I've made a web page in a vulnerable demonstration domain that simply reflects whatever input that is provided inside the get parameter XSS. This PHP page places the value passed in for parameter ID into a variable named name. It then writes the passed-in value directly into the response. To run this PHP code, you need a PHP-enabled web server, like Apache or Nginx. Save the code into a file named welcome.php. Place this file in the appropriate web server directory. Now, we will have to start the Apache 2 server. Once the Apache 2 server is started, we can access it from the browser. Let me input a name. Because the web page does not validate the passed-in value and displays it verbatim on the response page, this page is vulnerable to an XSS attack. Instead of Bob, an attacker could pass in a script such as the following to simply pop up a dialog box. In that case, the resulting web page would look more like this. As you can see, the passed-in script was executed within the client-side browser. The alert box proves that the web application is vulnerable to a reflected XSS attack. Now, let's take a look at stored cross-site scripting. An XSS flaw is called persistent or stored when the injected data is stored on the web server or the database, and the application serves it back to one or all users of the application without validation. An attacker whose goal is to infect every visitor to the website would use a persistent XSS attack. This enables the attacker to exploit the website on a large scale. Typical targets of persistent XSS flaws are web-based discussion forums, social networking websites, and news websites. Persistent XSS is considered to be more serious than any other XSS flaws, as the attacker's malicious script is injected into the victim's browser automatically. It does not require a phishing attack to lure the user into clicking on a link. The attacker uploads the malicious script onto a vulnerable website, and it is then delivered to the victim's browser as part of their normal browsing activity, as XSS can also be used to load scripts from an external site. This is especially damaging in stored XSS. When injected, the following code will query the remote server for the JavaScript to be executed. The application is an online forum where users can create accounts and interact with others. The application stores the user's profile in a database along with other details. The attacker determines that the application fails to sanitize the data kept in the comments section and uses this opportunity to add malicious JavaScript to that field. This JavaScript gets stored in the database of the web application. During normal browsing, when an innocent victim views these comments, the JavaScript gets executed in the victim's browser, which then grabs the cookie and delivers it to a remote server under the control of the attacker. Recently, stored XSS has been used on multiple sites across the internet to exploit users' websites as workers for cryptocurrency mining or to form botnets of browsers. Demonstrating stored XSS. Let's take a look at an example stored XSS vulnerability. Here, we'll use the Mutility web application from the OWASP BWA VM that we introduced in our previous video. If you have not yet watched that video, then watch it now by clicking the I button now. To follow along, browse to the IP address of the VM. From here click on OWASP Utility to link. Now, log in with the username, user and the password, user. Now, click the Add to your blog link in the left margin's A3 cross-site scripting section. Whenever a user insert new blog content, it will prompt on View Blogs section. In this example, we will be posting an entry to the user blog, storing a tag script for an unsuspecting victim to view. The website http://hackers.org contains a convenient demonstration script we'll use for this example. The blog entry then would look like the following. JavaScript file, to which we are linking, contains the following script. We will have to save it with XSS.js. To host this file locally, we will have to copy this file to the web server directory. Since we have added an URL, so we have to add hostname. When we click on Submit, and then simulate viewing the blog as an unwitting victim, by clicking the View Someone's Blog link, and then selecting Author and then click to View Blog. The attack script stored at hackers.org runs in the context of the utility website. Now, let's take a look, DOM-based cross-site scripting. The third type of XSS is local and directly affects the victim's browser. This attack does not rely on malicious content being sent to the server, it uses the Document Object Model, DOM, which is the browser's API, in order to manipulate and present the web pages. In persistent and reflected XSS, the script is included in the response by the server. The victim's browser accepts it, assuming it to be a legitimate part of the web page, and executes it as the page loads. In DOM-based XSS, only the legitimate script that is provided by the server is executed. An increasing number of HTML pages are generated by downloading JavaScript on the client side and using configuration parameters to adjust what the user sees, rather than being sent by the server as they should be. Anytime an element of the page is to be changed without refreshing the entire page, it is done using JavaScript. A typical example is a website that allows a user to change the page's language or colors, or resize the elements within it. DOM-based XSS makes use of this legitimate client-side code to execute a scripting attack. The most important part of DOM-based XSS is that the legitimate script is using a user-supplied input to add HTML content to the web page displayed on the user's browser. Demonstrating DOM-based XSS. Let us consider the following piece of code to better understand DOM-based XSS. To test the code and see the personalized greeting, firstly, save this lines of code with an .html extension, for example, domxss.html. Now, open this file, which will load in web page on the web browser. The web page will load, and the JavaScript code will retrieve the name from the URL's hash value and display a personalized greeting. Remember, to provide a name in the URL hash, you can append hashtag followed by the name you want to display. For example, to greet the name Technoscience, use hashtag Technoscience after the URL. Now, as you can see, the greet name is displayed, which is taken from the location.hash attribute. If the input in this instance contained a malicious payload, such as cross-site scripting attack, then what would happen? In the given scenario, an XSS payload is inserted into the location.hash property of the URL. This payload is then written to the web page's DOM using the document.write function. The payload consists of a code that tries to load an image from a specific location, X in this case. If the image is not found, it triggers the execution of the console.log function. As a result, the payload is executed, and the console.log statement is executed, potentially leading to the output of a message or information in the browser's console. Open the browser's console by right-clicking on the page and selecting Inspect Element. In the Developer Tools panel, navigate to the Console tab. In the console, you should see the output 1234 logged, indicating that the console.log 1234 code inside the onError attribute was executed. In DOM-based XSS, the attack payload is injected into a web page's input or source code, and it later reaches a specific part of the web page called a DOM sink. This DOM sink, often represented by a function like document.write, directly writes the payload onto the page, causing an XSS vulnerability. This type of XSS differs from the usual XSS because the attack occurs entirely on the client side, without involving communication with the server. Now, let's take a look at the attack possibilities with cross-site scripting. Our demonstration XSS attacks have simply displayed an alert box or displayed text and a cookie ID on the page. While these examples have only displayed information, far more damaging attacks are possible. For example, the malicious script could post the cookie values to an attacker's website, potentially allowing an attacker to log in as the user or resume an in-process session. The script could also rewrite the content of the page, making it appear as if it has been defaced. Cross-site scripting, XSS attacks can be used in a variety of ways. Stealing credentials. Attackers can use XSS to steal user credentials such as usernames and passwords, session tokens, and other sensitive information. Defacing websites. Attackers can use XSS to change the appearance of a website, including adding or removing content, changing images or logos, and altering the layout or design. Malvertising. Attackers can use XSS to inject malicious ads into legitimate websites, which can then infect the user's computer with malware or other malicious software. Phishing attacks. Attackers can use XSS to create fake login pages or other forms that trick users into entering their credentials or other sensitive information. Session hijacking. Attackers can use XSS to steal a user's session ID, allowing them to hijack the user's session and perform actions on their behalf. Cookie theft. Attackers can use XSS to steal user cookies, which can then be used to impersonate the user and perform actions on their behalf. Key logging. Attackers can use XSS to log keystrokes made by the user, allowing them to capture passwords and other sensitive information. Attackers have recently leveraged XSS vulnerabilities on popular social networking sites to create an XSS worm, spreading from one user's page to another. XSS worms could be leveraged to perform denial of service or brute force attacks unbeknownst to the user. A fun way to explore the power of XSS attacks is to install the browser exploitation framework, Beef. There is a complete tutorial video on my YouTube channel. If you have not yet watched that video, watch it now. Exploiting a victim using an XSS vulnerability can turn their browser into a zombie controlled by the Beef command and control interface. Beef can force a browser to visit a malicious website, log keystrokes, detect if a browser is using Tor, perform port scans, and even run Metasploit attack modules. It's a great demonstration of the power of cross-site scripting attacks. If there is any doubts or queries regarding to my video, then write them in my comments section.